So as we know, in yesterday's class, we discussed what is the curve or what is a graph for stress and strain, and we have been gone through the different levels of this stress and strain. So at the initial, like we have seen that 0 to A, B, C, D, and E point. So different points we used to call it as different names, and everything I have been explained in yesterday's class very clearly. I hope you all clear with that, everyone. So here the most important point you have to remember the B point. So B point is call it as, what is the name of the B point, everybody? B point is call it as a elastic limit. Do you understand it? And once the C point it will attains. The C point is not a permanent step, permanent point. But once the C point is attains, so that C point we used to call it as a what? At that point from C, it will attains the what? Yesterday I have taught you. It will attains the, yes please. From 0 to C, we used to say permanent set it will take place. So that is why from B to D, we used to say there is no elongation of a spring. So up to from O to B, we used to say, or 0 to B, we used to say elastic region. So the main points alone I'm talking. So elastic region. And then next from B to C, if you have noticed it, B to D, we used to call it as a, what is the reason we used to say, everybody? Plastic region. Clear? And D is, what is the call it as? D is call it as, everybody, maximum stress. So that is what we studied. Or maximum stress also we can call it as a breaking stress, we used to say. After that, if the still there is a applying force is increases, then the metal will flow like a liquid. That is what the wire will flow like a liquid. That is what thinning of wire will takes place. And once it will reach us to the E point, that is a point we used to call it as a rupture point. So these are the things we have discussed in our yesterday's class. And we have been made a conclusion, you might remember. So we have made 3 conclusions totally. What is that conclusions? Anyone can tell? We have made first conclusion number 1. So what is the conclusion number 1? So that is what a ductile, or we can say tensile. So tensile is high in which region, everybody? It is extremely large or more in a plastic region. So the plastic region, the ductile or tensile is very, very high. So then next one, if the given substance is brittle in nature, for them, a plastic region is very small, and there is another kind of substances which we used to call it as a elastomers. So elastomers, what is the specialty of them, everybody? No plastic region, is it right? So no plastic region is existed in the elastomers. Even we have been made examples which is called it as a rubber. So I think have you watched yesterday's video? Unless you watch, it is difficult to understand this question, but you have to watch it. Okay. So now based upon this graph, all of you remember. So they asked the question in JEE Advanced 2015. All of you write it. So after this question, next concept will start. Then maybe you may understand that. Okay. So now JEE Advanced 2015, all of you remember they asked the question, draw it and answer it. Multiple answers are correct. Remember, advance is always multiple options will be correct. So you cannot stick with the one answer. So there will be a more than one answer. You have to verify. So I'm drawing now one graph is this. You can notice it. This is the graph number 1. So that point, let me take it as a Q point. So from here it will attain the, we'll check it. We have to prove it. So this is the graph number 1. And the next one is this is the graph. This is the P graph and this is the Q graph. Now, options I am giving you. You all should try to find it and you have to do it. Okay, everybody. So option A, P has more tensile strength. P has more tensile strength. Next, B, P is more ductile. Next, C, P is more brittle. Next, option D, Young's modulus of P is more than that of Q. So multiple answers are correct. You have to find the correct answer. So this is what is about it. So let us see how to solve it and how to make it. So now, so what is a graph actually, brothers? This graph is related to between a strain and a stress. So stress is in x-axis and strain is in y-axis. So similarly, like you all should remember, all of you. So we all know what is a graph of this one. Anybody can tell basically? Slope is equals to what? Will gives you strain divided by stress, whatever it is there. So, but basically you have remember that just now we have seen the graph. Basically, we'll draw the graph for what? Like a electricity chapter, brothers, like we studied in 10th class. This is a graph actually is a what? Stress versus strain. Am I right or wrong? Please respond. Stress versus stress.
Yes.
Stress versus strain it is. But here, what is the slope formula? So here the slope is equals to, we'll get what is the formula? We'll get it. Stress divided by strain. So that is what we used to get it, a Young's modulus, or is a bulk modulus, or it is what is that? Shear modulus. Whatever it is, modulus of elasticity. So modulus of elasticity is equals to stress by strain, which is equals to slope. So that is what strain versus, stress versus strain graph. Y-axis is always very important for us. Class 10th electricity chapter, what you studied the same thing. So IV graph and VI graph. So always we have VI graph. So x-axis, y-axis V and x-axis I. So if I have taken a two graphs, who is having a greater slope? Anybody can tell first? Let me take this is A and this is B. Who is having a greater slope? A or B? B is having a greater slope. Am I right or wrong? Please respond. Angle. So resistance of B is greater than resistance of A. Like that we studied. Do you remember? Yes or no? Ma? Respond. All of you. The same principle here we are using. So actually book we are studying stress versus strain. But here they have given what? Strain versus stress. So by the time Young's modulus, as it is extension, it is related to length. So slope is not equals to Young's modulus. So it is slope is equals to something is Young's modulus. Can you tell me, everybody? What is that? Those? That is what 1 by Young's modulus is equals to slope. That is what strain by stress. So by the time you might be remember class 10, while we are studying the IV graph, for example, I is in y-axis and V is in x-axis. So by the time we have been done what? R is equals to resistance is equals to not slope. It is not slope. Here in this case, R is equals to slope of the graph. That is what we have done. V2 minus V1 divided by I2 minus I1. But here, so R is equals to I2 minus I1 divided by V2 minus V1, which is actually equals to slope. But it is not equals to R because R is equals to 1 by slope. So means in the sense of 1 by I2 minus I1. So we'll get 1 by slope is equals to resistance will come. So that is what it is not slope is equals to not strain by stress. Basically, we know slope is equals to stress by strain. But now they have given here strain by stress. Means in the sense of what? Ulta. So that is what I'm taking a 1 by Young's modulus. Still here, any doubt you have, you can ask me. Understand, Pradosh? Clear?
Yes, sir.
Yes. So now, so we all knows that if I take it now, if you observe it is a strain versus stress. So who is having, forgot about the x-axis and y-axis. Who is having a greater angle? Everybody, P or Q or? P or Q or? Who is having greater slope? Anybody can tell? P or Q, who is having a greater slope? Everyone? P. Am I right or wrong? Please respond. So slope of a P is greater than slope of a Q. Is it right or wrong? Do you all understand? All of you?
Yes, sir.
So, but here
Yes,
it
sir.
is strain versus stress. So means in the sense of slope of P means what will come? 1 by Young's modulus of P, which is greater than 1 by Young's modulus of Q. So now, reciprocal if I do it, what will happen? Which is greater? Q is greater or P is greater or? Everybody, Young's modulus of Q is greater than Young's modulus of P. Do you understand? Clear, Laksha? So means in the sense of that is what is the stress.
Yes.
So stress of Q is greater than stress of P. So that is what you have to remember. So everybody, so as it is P angle is greater, so that Q angle is less. So that is why the slope of P is greater. But slope means what? 1 by Young's modulus. So 1 by Young's modulus of P is greater than 1 by Young's modulus of Q. If I do the reverse, then it will be entirely reverse. Q, Young's modulus of Q. 1 by Young's modulus of P is greater, but opposite, Young's modulus of Q is greater than Young's modulus of P. So this is what the result I concluded. Now you can go to the options, all of you. So Young's modulus, who is greater, Q or P or? Who is having greater Young's modulus? All of you. Who is having greater Young's modulus? Q or P or? Q is having.
Q.
But here they have given option. Young's modulus of P is more than that of Q. So option D is wrong. Next, P and Q, you check it. Who is having more B2D region? B2D region, who is having more? This is C. It ends by here itself. But here it is going and taking and again going. So who is having more plastic region? Brittle. Everybody, P or Q or? It is already breaking here itself, but it is taking more time. You can have noticed that B2D is having a elastic, that's what, plastic region. So now who is having a brittle in nature? Q or P or? Who will fastly breaks? You can see. So Q. So graph is small means that is what is the brittle. So who is the brittle in nature? Q or P or? Everybody. Who is the brittle in nature? Q. But here they have given P. So option C also wrong. Next. P has more ductile because more B2D graph is there. If the B2D graph is more, then what will happen? It is both ductile and as well as, also we can call it as a what? Tensile, both tensile strength, holding capacity and stretching capacity. So both option A and option B both are correct. I hope you all understand it. P has more B2D region, plastic region. Plastic region is high for B2D, so that P has more tensile strength, and as well as P is more ductile also in nature. Means it can be stretched without breaking. That is what you have to remember. So this is one of the advanced question, JEE advanced. You see that if you are good in concept, how simple it is. That's the reason I say, in this question, anybody having doubt, you can ask me, then I will proceed from. Are you clear, everybody? Suppose if it is the stress versus strain graph, then who is having greater slope? Anybody? Stress versus strain graph. Then also, who is having greater slope? Stress versus strain graph. Then also, P is having a what? Please respond. P is having greater than Q. Slope. Do you understanding? So slope of a P is greater than slope of a Q. But here, by the time slope is equals to what? Respond. By the time slope is equals to something. What is that? It's not that you don't need to do necessary to inverse. So by the time slope is equals to what? Speak, guys. Young's modulus. Do you all understand, everybody? Understood or not, Ma? Please respond. So that is,
sir.
so if it is, if it is the stress versus strain graph, slope is equals to Young's modulus directly. But if it is the slope versus strain, that is what, stress versus strain graph, then sorry, strain versus stress graph, then definitely there will be complications. That's what 1 by Young's modulus, like that you have to do slope and all, you have to be careful. So this is what is one of the most important question which is asked in 2015 JEE advanced, not even mains. I hope you all understand. Anybody having any doubt, you can ask me, or else we'll move to the next question. Are you clear? Please respond. Do it, everybody.
Yes, sir.
Yes? Brothers, are you clear? Yes? Okay. Next. Any doubt, anybody can ask. Till here, are you having doubt? Finish it. Then the next concept we are going to study, as we studied, 9th class itself, we might be studied that potential energy is two types. That is what EP, or you can say, we'll represent with the symbol U. Potential energy U is two types. What is that, everybody? Can you tell me? Potential energy is two types basically. One is gravitational potential energy. Next one is elastic potential energy. So note it, I'm not going to make it anything. Due to the position of the object above from the ground, the energy possessed by a body is called it as a potential energy. You might be studied already the formula. Potential energy is equals to mass into acceleration due to gravity into height above from the ground. That is what 9th class also you might be studied. So by the time, if you are, even I taught, so those who are my students, you can remember. So elastic potential energy means the energy possessed by a body due to change in shape or size of a object. So that is what is the energy. We used to call it as a elastic potential energy, which is possessing by the body or occurring in the body because of by changing shape or size. Like you can take example, compressed spring. So suppose I compressed the spring, and if I release my hand, then what will happen? The spring will fly and it will fall somewhere else. Or else we can take inside your watch, there is a we can say spring-like structure. So basically it will be compressed and it will be keep on oscillating, so that only the seconds needed, whatever the needles, the mechanism, the energy compressed spring, if you have taken, it is also possessing a potential energy. When it will be coming to the normal position, it is compressed, so it will possess elastic potential energy. As soon as you release it, it will be come back to the original position. Because as we already studied, do you all remember that elastic potential energy is causing because of due to change in its shape or size. So that is what you have to remember it. So now, today's class we are going to discuss what is the energy. That is what elasticity, energy stored in a stretched wire. That is what exactly like a spring. If it is a stretched wire or a stretched spring or some other XYZ object, the energy stored in it due to the shape, due to the size of the object, the energy possessed by the object is changing. So that's why we are going to see that energy stored in the body is what is that energy and what is the formula, how to calculate it. That is all we are going to discuss now. So if you have taken, first I'll teach the formulas and then I'll teach you the derivations. So we already studied that elasticity, modulus of elasticity is equals to, what is the formula? It may be Young's modulus or maybe bulk modulus. What is the formula for elasticity, everybody? Elasticity is equals to what? Stress divided by, please respond, stress divided by strain. So from that, I will say stress is equals to, I will say modulus of elasticity into strain. So please, all of you remember this. Then you can understand. Keep heading, all of you. Energy stored in a stretched wire. This is also important concept for JEE and as well as NEET. So energy stored in a stretched one. So if it is stretched means automatically what energy will be stored? Everybody. What energy will be stored? Potential energy or kinetic energy? Everybody. Stretched it is. So due to the position, shape is changing. So that what is that, everyone? Speak, guys. It is a potential energy or kinetic energy? Due to the shape is changing. So it is a potential energy or kinetic energy? Please respond. Potential energy due to the shape and size. So potential energy U is equals to, write the formula, later we'll derive, half into stress into strain into volume. So you never feel, all of you remember. So it's very, very important. You no need to think about anything. We'll study the derivations also. So this is the formula for potential energy of a stretched wire. So note it. Do you understand it? As of a stretched wire, this is the formula. Now, the same formula if I write, the potential energy possessed by a body for unit volume. For unit volume, that is very important. Potential energy possessed by a body per unit volume is equals to, volume come this side. So what is remaining? 1/2 into stress into strain. So that is what is the another formula. Potential energy per unit volume. So potential energy per unit volume, just now we studied. Potential energy per unit volume is equals to half into, here in place of stress, what else I can write? All of you see that just now we have written in place of stress, what I can write, everybody? Young's modulus into, or elasticity, modulus of elasticity into, what I can write? Speak, guys. That is only important formula. So in place of stress, can I write it as a E into strain? Any problem? Anybody? You can ask me. And again, this strain is there. So that is what is the strain. So potential energy per unit volume. Potential energy per unit volume is the another formula That is what half into E into notate strain into strain. We used to say that strain square. So this is the another formula for potential energy per unit volume. So that is very, very important. So hope you all understand. So these are the three formulas for calculating the potential energy for unit volume. So as it is, you can remember this E modulus of elasticity may becomes Young's modulus or shear modulus or maybe bulk modulus. So now, if you notice it, everybody, as it is considered as a wire. So wire is having only one modulus. Anybody can tell? That is what we used to call it as a what? Longitudinal stress or strain. So who is handling that? Longitudinal stress or strain. There is a one who is to call. What is that? Modulus. That is what? Please respond. Young's modulus.
Young's modulus.
Please remember that. So as it is a wire, definitely it is a solid, so that it will speak about only Young's modulus. I hope you all understand. Anybody having doubt, you can ask me, or else we'll go with the derivation. Are you clear, everybody? Yes, please. So now, yes, brothers, anything doubt?
No, sir.
Yeah. Understood? What is the potential energy formulas? So understand the potential energy formulas. So now, I just remember I'm having a glass rod. So here you have to remember many things. So I'm having a glass rod whose length is L. So let me consider whose length is L. Now, because of applied force continuously, so we all knows that if the force is applying downwards, there is a force which is acting backward direction. What is that? Which is restoring in not. That is call it as restoring force. Am I right or wrong? Please respond. Restoring force, but still okay. So now, this object is extended to a L distance. The length of this rod is extended is a length of a rod. So for example, if I taken this length rod also same, and if you have noticed it here, all of you. So that is what we is to say, basically L, and remaining part we are going to say it delta L. So that is what is the extension from the initial position. So that is the extension. So L, it is changed, it is increased the length because of the force. That is what dl. So now, if you observe very carefully here, we all know that Young's modulus is equals to force into length divided by area into change in length. This is the formula. So formula we are getting from Young's modulus is equals to stress divided by strain. So stress is equals to what we used to call, everybody? Stress is equals to, make it quick. Stress is equals to what, guys? Force by area. Strain is equals to what, everybody? Strain is equals to, what is the formula? Array, too much, ra. So this is the Young's modulus formula. So now if you have taken, so what is the formula? Now if I take the force, so force is equals to what? Young's modulus into delta L into A. This will come this side divided by, you can notice it, L will come. So that is how it has been done. Now according to this, if you observe, the force, if the force increases, here delta X, length is also going to increase. So both are directly proportional, inversely proportional. Everybody, both are directly proportional to each other. So now this length dl. Now suppose Mr. Pradosh is applied 1 Newton force, so maybe this much is extended. He applied 2 Newton force, maybe extend this much. 3 Newton force, maybe extended this much. Or 4 Newtons, maybe extended up to this one. So now, but what I want to say here, everybody, you must able to identify what is how the length, the applied force is working. That is very, very important. So kindly make it. So as we studied, force is directly proportional to delta L. So then work done is equals to, we all knows that force into displacement. What is the displacement, everybody? Delta X. What is the displacement, everyone? Displacement is how much? Delta L only. Am I right, Ra? Respond, everybody. That is call it as delta L. So in place of force is okay. Yes means I will write a delta L. Now, is this force is remains constant or variable? That is what I want to ask you. Suppose I may apply the force little extension. Some other will apply the force some more at extension. Some other person will extend. So maybe that is the length will be keep on changes. So that is why. So we want to find the total length. Then what we have to do it? We have to go with a certain concept. What is that concept? So let us take, it is not a new concept for us. So which we are studying long back. So you can notice it. I am imagining. So up to here, the length is same. So now the question is, so here it is every time the force is applying, so that variation of impact of force maybe keep on changes. So that little amount may increase, little amount may increase. So but that is what it will be happening. So the original length, if you have noticed it, that is L, and there is a small change in the understanding. So that is what is the small increasing in the length. That small increasing in the length I am considering as a DL, or you can consider as a X. So I am considering as a X. So now, so every time if you are notice it, everybody, at the point A, whatever I have taken. So at the point, let me take now for example. So here what is happening? The applied force is not remains constant, so that we cannot say that the elongation of the spring or a rod is not uniform every time. So applied force is not a fixed force. What is the force actually? It is the, speak loudly, it is the variable force. So just now we studied work done is equals to force into understanding change in length, but the applied force is not equal. So applied force is not equal, so that the extension of the spring is not continuously will be the same. So that is what. So as the force is variable force, immediately we have to do something to find the total extension. So we have to do something. Anybody can tell? That is what we used to call it as a integration. Am I right, Ra? Please respond, everybody. So integration of F2. If I take, this is the delta L is a what? Anybody can tell, Pradosh? Delta L is the total change in length. Total change in length. But you can see what will happen, everybody. There is every time very small extension is there. That extension only we used to call. What is to call? So it is not a big as noticeable change. So there is a small extension of that. So that now you tell me. So what will happen? This X in that X part, there is a small X distance is varying. That is what I consider as a dx. So if I consider as a dx, then work done is equals to not F into dl. So I'll take it as a F into dx, because a very deepest and very finest, there is, you can see overall length is, overall change in length is delta L. But there is a small change in every kind of variable force. So that is what you have to remember it. So that is why W work done, if you have taken, is equals to integration of F into dx. So or F into dl, whatever it is. Now, if I, so as the work done is extremely small in stretching the wire by how much actually dx. So if I stretching the dx distance, the work done is extremely small. If you have taken extremely small enough, so that what will happen actually, so that when it is stretched x amount, then we'll consider very small it is. So I will consider as a dw. So dw is equals to F into dx, extremely smaller. So dx means what? Extremely small. Small change is taking place. So I'll take dw is equals to F dx. That is what we used to call it as a small amount of work done. So now, let us see, we all people will find that and will prove it. So now we all knows that Young's modulus is equals to, what is the formula actually? Stress divided by, at least speak this, stress divided by what? All of you, strain. So from that we'll say F divided by strain is equals to what? Delta L by L, which is equals to F into L. Do you understand? F by A. So what will happen? This L will come divided by A into delta L. So I hope you all understand. Please respond, Ra. Everybody, clear? From that, can you tell me what is the force formula? Force is equals to what? A dl will come this side. So Young's modulus into A into dl divided by L. So this is the force formula. Force is equals to this much. So now I got it, the force. So we got the integration concept, because very small change I have taken. So small work done. So dW is equals to, if you have noticed it, so what is the formula? We got it, f dx. So I will apply the integration. So integration of dW is W. Now integration of f value is how much we got it? Young's modulus into A into delta L divided by L. So into D, into what? Dx. So if you have noticed it. So now, if you all observe very carefully, actually this DL, I will change it as a very small change. So that is what I am considering as a what actually. For a small change it is happening. So that small change I am considering as a what, everyone? I'll consider as a X. So that small change I am considering as a X. So now what will happen? This formula will be changes into integration of Young's modulus of A into dx, sorry, X into dx divided by L. So now what will happen? Few things are remains constant. So integration of dw is W. So now here what is that? Young's modulus is constant, A is constant, and L of the length of the wire is remains constant. So what is remaining, everybody? So X dx. So and limits is varying from where to where? The change in length, the change in total length is delta L. So starting point is 0 and ending point is delta L. So that is what is the limits, 0 to delta L. So now if you notice it here, so apply the integration of x dx. What is the formula? Integration of x dx, x plus x power 1 plus 1 divided by 1 plus 1, which is equals to x square by
X square by
x square by 2. So now Young's modulus into A divided by L, which is equals to x square by 2, and limits is from 0 to delta L. So now what will happen, everybody? Young's modulus into A divided by L, and in place of x will substitute as a delta, that is what dl whole square divided by 2. Now I will bring this 2 outside, I will write it. So Young's modulus into A divided by L, and I will write delta L whole square. So now you can see both numerator and denominator I will multiply with L and L. So why I am multiplying, you will understand. So keep it, everybody, both numerator and denominator I will multiply with L and L. So now if you have noticed it, everyone, here I will write this half separately, okay, into here. If you notice it, L into L multiplication if I take, okay, so L into L square and up delta L square into remaining, what is remaining, everybody? Young's modulus into A into here last L is there. So this is what is we have. So now we already studied area into height or length, which is equals to gives you what, everybody? Area is a 2 dimension. Yeah, volume it will give. So it will become 1 by 2 into delta L by L whole square into Young's modulus into A into V, we used to call it as a volume. Okay, va? Ellame understood till here? Please respond. Now, delta L by L is called as something. Can you tell me what is delta L by L, which is equals to something, Pradosh? Delta L by L is called it as a stress or strain, which we used to call it as a strain. So which is equals to half into strain whole square into Young's modulus into volume. So this is what you have to remember. Now, this strain I can write it as a 1 by 2 into volume into I will write this one as strain as a 2 things. How it will be, you can see. Strain into Young's modulus into strain. Any doubt in this? You can ask. Can you write it or not, for those? Like this we can write. Clear? Yes. So volume into strain into stress we can write. Of course, it is what. So now if you all observe very carefully, so we all knows that half into, let me take it as a volume, no problem, and one strain is also no problem. So now normally Young's modulus is equals to, we all knows that stress by strain is the formula. Now from that strain into epsilon, sorry, Young's modulus is equals to stress. So in place of strain into Young's modulus, I can write what, everybody? Please respond. I can write as a what? Everybody respond, which is equals to stress. That is what is the work done. So we all knows that amount of work done, which is equals to energy possessed by the body or energy inside by the body. That is what work done is equals to that. So that is the formula, half into